Hi everyone, welcome to this session. This is the final session of Codenames, the AI bot competition. We're excited to have you here, and your hosts are Dan Hilgert and Yuri Scheilachter. Before we get started, I'd like to thank our sponsors in support of TWIML in today's session. And please send any questions you have into the chats. We'll be monitoring there. And I'll turn it over to your hosts.
All right. Let me share my screen. How's everyone doing? Can you hear me?
We can hear you. Yeah, thanks. I'm fine.
All right. Cool. Well, we made it. It was quick. 2 weeks goes fast, but the Codenames competition is done. We will announce the winners here shortly, but first I've got a couple. Let me move this out of the way. A couple things to share. So we're going to go through some interesting statistics from the week 2 competition, and then we'll review. Okay, so we had these bots and they were running on the server, and we don't really know what they did while they were running. So let's take a look at some of the best clues and see how they went. And then we will look at the official leaderboards and see who the winners are. And then we can spend some time discussing different strategies and approaches at the end if you want to do that. So without further ado, here's the week 2 stats. So the entrants on this in the competition played collectively, started almost 1,200 games over the course of 1 week. 13% of those timed out. So that left us with 1,048 games actually completed. The average number of rounds was 4.3. So that's where 1 round is a turn for each team. So a team 1 turn and a team 2 turn is 1 round. So that's probably pretty similar to human play, I would guess. We had, unlike human play, the number of percent of correct guesses was almost 100%, very close. The bots were not very risky, the guessers at least. And then the percentage of games that ended in an assassin word was very low, only 1.5%, which goes along pretty closely with the percent of correct guesses. Team 1 versus team 2 was fairly balanced. Team 1 won 47% of the time, so team 2 won 53. So it didn't matter a whole lot which team you started on. So that's good. So we had 9 times over the course of the week that one of the bots gave a clue for 7 and their partner correctly guessed all 7 words. So when you think about team 1 starts with 9 words and team 2 starts with 8 words, the fact that you can get 7 of them sets you up at a huge advantage. And I was very impressed that the bots were able to come up with words for that many. So I put a bunch of them on here. So I started building this deck earlier today. So there were 8 of them at that time. This 9th one, game 1817, came in after I built the deck, so I don't have that one. But I've got 8 of them. Interestingly, 3 each from 3 different competitors. So 4680 had 3, 2907 had 3, and 3154, that's me, had 3 as well, of these clues for 7. So that's kind of interesting. So let's take a look. What does a clue for 7 look like? So here's the first one. So this was fairly early in the week. And this was 4680 was the Spymaster, the clue giver, and playing with template bots. So for the purposes of this, I've always made team 1 blue and team 2 red. It doesn't really matter, but just to keep things straight. So he gave a clue spot for 7, and this is the board. Does anybody want to take a guess at which words he was trying to tie together with spot?
So camp spot would be an obvious one, maybe.
Okay. What else do you see?
Ooh, that's difficult.
So I saw spotlight goes together.
Oh yeah.
But I didn't get much further than that. Let's see what the bots came up with. So spotlight was first. Line, line spot, spotline, not exactly sure. I guess they're both geometric, maybe somewhat related. Camping spot, yep, I had that one. Deal, I have no idea how that's related to spot. Pizza, yeah, I guess you could say like a pizza joint, pizza spot. A billboard, like an advertising spot, maybe. I don't know. It starts to get kind of stretch here at the end. Opinion. That's the 7th. So yeah, I would not have gotten 7 if I were the guesser, but here's what the official board looked like. The key. So yeah, so that was an interesting one. Stick for 7 was the next one. This is 2907 is the Spymaster playing with template bots again. Anyone want to take a shot at this one?
Igloo.
Okay, igloo.
Oil, like a dipstick.
Yeah. Yeah, okay, I see that. I'm thinking maybe swarm. Like you could have a swarm of bees around a stick. I don't know. Let's see. Let's see where
Light,
the bot
like a
went.
light stick.
Okay, so it went with push. I guess you push a stick. Yeah. Dump. Okay. Ear. Stick something in your ear. Light stick. Yep, there's one. Lift. Like you lift a bundle of sticks, maybe? I don't know. Raw. No idea how that connects. Oil, there's your dipstick. Swarm was wrong. Igloo. Igloo was one of the blue words, but not one of the ones that the guesser guessed. So it's interesting. This one was a team 2. So now they only had 8 words to guess. So this one was 7 of the 8 words tied together with 1 clue. So they only had 1 word left after this. So this was my bot. And so far for 7, I'll just go through these a little quicker now. Prevent, production. I have no idea how these are tied to far. Sweet, candidate, angle. Okay, angle I can maybe see. Cheap, transportation, that makes sense. But those were in order from most confident to least confident, or smallest distance to largest distance. And the ones that made the most sense to me were lower in the list. That was kind of surprising. So apparently the bots know something that we don't. Here's one, towel for 7, sink, mirror. These are kind of making bathroom, it ties to bathroom, steam, yeah. Relax, lemon, okay, maybe a spa. Sun, yeah, cuff, not sure. That was that one. We got a couple more. Every for 7. This one I was completely confused by. Well, nature, brand, operation, suite, cook, couch. I really have no idea how those tie to every. Everybody, okay, this is a team 2. So the team 1 had already knocked 4 off the board at this point. So team 2 had a few less bad ones to interfere. So let's see where they went. Everybody, a crowd, okay, that makes sense. Assure, maybe. Will, Sunday, fan, story, later. Yeah, I don't know. Starts to get kind of weird. We can, if you're interested, you can look through these afterwards. I think we've done enough. So let's get to the part that everybody is waiting for. The winners. So are we ready? Here we go. Okay, so 4680, if you're here, stand up and take a bow. So we only had 2 official entries, 2 eligible entries. So Yuri and myself were ineligible, so we're not on this leaderboard. But yeah, who was 4680?
Hi, it was me.
Congratulations.
Thank you. Thank you. It was really, really fun.
Well done.
Loads of fun, honestly.
Good. How about 2907? Is 2907 here?
That was me, Johannes. Thank you.
Great. Well done. Yeah, so let me move on to the full leaderboard. So this has got everybody. So this is 3154 is me. 1062 is Yuri. So we were both ineligible for the prizes. And then the rest were the template bots. We did have, for a short time, 5048 showed up for 35 games. As an operative, but his Spymaster was timing out, had some sort of error, and then never came back. So he didn't meet the 100 game threshold. But yeah, this is what the full scoreboard looks like. It's interesting that the Spymasters are much more teased apart. The operatives are much tighter together. It only ranged from 1440 to 1582. Seems like it was much harder to do significantly better as an operative than it was as a Spymaster. The template bots, as expected, moved towards the bottom of the list as Spymasters. They were only giving clues for 1 for the most part. They occasionally gave clues for 2, but that put them at a huge disadvantage when their opponents were giving clues for 5, 6, 7. Hard to win that way. What else do I see here? Interestingly, my bot had a slightly better win percentage than Anthony's did, but his had a better elo. So that's interesting. What else? Yeah, so that said, anybody want to share their approach? Anthony, a winner, you want to go first?
Yeah, sure. So for as a Spymaster, first of all, can you hear me clearly?
Yes.
All right. So as a Spymaster, I did some modifications there are two main parts of my Spymaster. The second part is that instead of doing combinations of good words, I just ran through all the candidate clues that I had, and for each candidate clue, I generated an array that had like the distance with the unguessed good words, and then I sorted this array, and I would check, okay, how many first, like how many good words do I have first in my array? And so I only had to do it for each candidate, and I didn't have to deal with combinations of good words. So that sped things up a lot. And the second thing is to add a lot of candidate clues. So the template clues are only about 6,000 words, but I searched around for like WordNet words and spacey. I dug up what the words that had vector representations in spacey, and I calculated their distances with the board words and saved them. So instead of having just one pickle file for the clue distances, I had multiple, around like 100,000 words, so that like I would have, I guess, a better vocabulary if I wanted to give better hints. And yeah, I guess that was it.
Yeah, it's very similar to my approach. I also use the entire spacey vocabulary as my words to pull from, or at least I use the uncased version. So I took the lowercase of the entire spacey vocab, which ended up being, I think, on the order of 250,000 words to choose from. And then I found a way to vectorize the distance calculation. I think I was using sklearns. So the distance calculation for those, between those 250,000 words and the 400 that were in the board, that the board could be generated from, that only took like 2 seconds. So that was super fast. I was surprised.
Oh, wow.
So that was awesome. And then I stored those in a pickle file as well, that 400 by 250,000 matrix, and use that. And then here, I can share my code actually. So once I had that, then I calculated the minimum distance between each of those, each of the bad words on the board, any word that wasn't a good word, and the distance between all the bad words on the board and the 250,000 words. So I could figure out which, for each of the 250,000 words, how many good words were closer than the closest bad word. And then for those, that gave me the number of guesses that I could reasonably get out of each of those 250,000 words. And then, but I also wanted to take into account, I knew that the template guesser bot had a threshold. And so it wouldn't necessarily pick all the words that were closer than the closest bad word. So it might pick a smaller subset. So I went and I figured out, okay, how many unthresholded guesses would I get for each of the 250,000 words, and how many thresholded guesses would I get? And then I tried to maximize the number of thresholded guesses, but I still gave my clue for the unthresholded guesses. So if I had a word that I thought would give six words, or say 5 words that were less than the threshold, but there were 2 additional words that were beyond the threshold but closer than the closest bad word, then I would give the clue for 6, if that makes sense, or clue for 7.
Yeah, I also did something similar, but I only allowed one good word beyond the threshold.
Yep. And then I just checked to make sure that the words were legal. I pulled in the legal clue function here to test to make sure it was legal, and anything that was illegal, I filtered out and moved on to the next word in the list. And I sorted it, my candidates, I sorted by how far they were from the closest bad word. Yeah. That was the gist of my function.
So I've got a quick question, I think. The Spymaster can't really be smarter than the agents though, right? Because if they can't or don't know those words, so is that how you made sure, is by filtering out the legal words, or making sure they're
Yeah, so I took advantage of the fact that I knew that the template bot at least was using this Spacey, the English Core Web Large to find its vectors. And so I used this as my source of possible clue words that I could give. So as long as the template, as long as the guesser wasn't using a different set of words, it should always have a vector for the word that I would give. Johannes, you want to share anything about your approach?
Oh yeah, it was quite similar to you guys. So yeah, depending on the guesser, using the same vector space for the word embeddings. But I used only about 30,000 words or so for the vocabulary. So that's probably the reason why it was hard to beat you guys. I didn't find an efficient way to calculate the distances. So my laptop ran overnight or so for those 30,000 words. And so I lost interest in putting even more words into this. So nice to hear that you found a way to do this in seconds compared to hours that my machine took for in just a basic way to do this.
Yeah, I also had to do run computations overnight. Over multiple nights, so and days.
Yeah, so the distance function, the cosine distance, ends up being, as a matrix operation, it's pretty simple. It's just a couple multiplications and a couple dot products. So it goes really fast if you've got it in matrix form.
Okay, yeah. Yeah, it's often always if you have to loop over something thousands of times, it's always slow. But I just didn't think of a way to do it more efficiently. Yeah, nice. And yeah, the rest was quite similar to yours and Anthony's approach. So just rely on the guesser to use the same vocabulary or the same distances, and just look which clue generates the most correct words in order. And yeah, I would have loved to find a way to be more flexible in case there would have been any other guessers, because I think then this strategy wouldn't have led too far. But I really wasn't sure about that, how you could be more flexible. I used initially in the first week when the competition wasn't running, I used the word to vector approach trained with Google News. And so these clues, at least in my opinion, were a little more sensible. Or so I didn't generate clues for 7 words, but the clues that were generated made a little more sense for us humans, I think. And so, yeah, I would really like to see an approach that's more maybe usable for a human competition, because like the examples you showed with clues for 7 words that just don't make sense for us, I don't think they're particularly interesting if we would like to use it in production or in a real game. But yeah, I didn't really have an idea to to generalize better. I don't know.
Yeah, it was tough breaking out of that when we
Yeah,
only had
yeah.
a handful of competitors and we knew
Yeah.
that most of our games were going to be against the template bot.
Yeah.
There wasn't a lot of motivation to make it more general, but it would be interesting. That's definitely a bigger challenge to generalize it better.
Yeah, or just to adapt to the behavior of your opponent or the guest or your teammate. Yeah. Did you guys have, or what were your ideas for the operatives? Because I tried a few things, but they all seem to work worse than random or worse than the template bot. So I quickly gave up on that. But you guys seem to have a little advantage over just 50-50.
Yeah, I for my guesser, all I did was increase the threshold for guessing from 0.7 to 0.8. I just made it a little more aggressive. That's the only change I made.
Okay.
Yeah, and I did that too. I increased it to 0.83 random number. Just I don't know. I liked it. And I tried doing something where I would kind of play the role of the Spymaster as an agent. I would see like, okay, after I guessed these three words because the Spymaster gave me a hint and number three, I would say, okay, what if it was for what's the closest fourth number, fourth word, and then I would see if it's like something below a threshold. I would say, okay, this is probably a bad word, and I would save it somewhere. But that did not work because, for example, if you have template bots, they won't give you the best combinations of words, and like they could have given you a higher number, and I would think that those extra words are bad, but in fact they're good. But the bot didn't just didn't notice or couldn't make it. So I dropped that idea too. There was one strange thing where the similarity function, like because in the as an agent, the similarity function from Spacey is being used, whereas as a Spymaster we're using the pre-calculated um, distances. So there were a few words that had different distances.
Oh yeah.
So for example, ID, capital letter I, capital letter D. It stands for identification. But if you write ID small letters and you try to see the distance between small ID and big ID, the distance is not zero, and it's different. So I guess when I'm running the computations, the distances were saved differently when changed to when the word was changed to lowercase. So I checked like as an agent, I first checked if I have this computation saved, and if not, then I would go use the distance function. But it was just only a few words. ID won't for some reason. Won't was also another word that had different distances between. Yeah.
I guess ID makes sense.
Lowercase makes, because it's id, right?
Right, which is like your ego. Yeah. Yep, it's completely different meaning. Yeah. That's one where the case really makes a difference.
So I was thinking how I would play against humans, and it would and actually if you look at the paper, they build a lot of, they discuss a lot of strategies, and they're based on WordNet, because WordNet gives you a lot of linguistic distances, so you can actually find linguistic relationships. Problem is when playing with bots is if bots are using similarity, so it's difficult to, and it's its own logic, so it's difficult to play against that. So basically it didn't make sense to come up with a better clues, because most of the guesses would be purely based on distance. So But I was thinking if I were to like extend it against playing against humans, like we used like spacey as default similarity, but with like modern similarity, modern vector representation, you can actually have multiple representation. So you can have like multiple meanings as separate vectors. So like I was thinking, like if this would to be extended against humans, I would take each word and maybe create few vectors for them, like for each meaning of the word, and then based on that, you can actually like try to do different relationships.
Yeah, and I thought of that too, in case there were competitors who didn't use the glove representations, but seeing as like the template bots already use the glove representations, and people will be more likely building on top of this, thought maybe it's not useful to mix glove and like other representations like bag of words and stuff. Like I was thinking maybe if I wanted to do that, I'd take I take many opinions, if you want, from the different representations and see like which words are agreed upon the most. So yeah.
Yeah, interesting stuff. I did have a thought early on about using like Bert embeddings and trying to come up with, is there some way that you could capture relationships between clue words and the words on the board through Bert or some variant of Bert, but I didn't end up pursuing that very far.
This could have the advantage that you could have context sensitive vectors,
yeah.
right? Okay.
Okay. Yeah. So like if you put a candidate clue word before one of the words on the board, you get an embedding. And if you put a candidate clue word after one of the words on the board, you might get a slightly different embedding. And if you put it by itself, then you might get a third embedding.
Okay.
You know what? This is what you can train that based on human games. So if you have like recorded human games, you'll get basically like scores or or human distances, and then you can fine tune like your presentation. So
Is word to vec dependent on the order?
No.
Okay.
I don't think so.
It's just things like Bert, right?
Yeah. 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 Word to vec collapses all possible meanings of a word into a single vector.
Mm-hmm.
Yeah. Cool. All right. Well, thank you all very much for competing. It was fun running it as well. Hopefully everybody enjoyed it. Any feedback? Anything we could do better next time? I mean, I know that we didn't have a whole lot of warning, just a week of practice and a week of the actual competition. I know it would have been nicer to have like a couple months to start building your bot ahead of time, but it was kind of a last minute thing. So next time we'll have more warning. That's for sure. Maybe we'll get more competitors that way. But anything else feedback wise?
No, thank you very much for providing the competition. It was a lot of fun. I know there was a lot of work and thought from your side in that, and unfortunately not too many took part in the competition. I don't know why. Yeah, it was a little on short notice, but I thought, I mean, I can spend a few days playing with it, but maybe most people would have, wished for a little more time. I don't know. Yeah, thank you very much.
Yeah, the Jupyter notebook was really helpful because it could really see what you
Yeah.
had built
Yeah.
and then focus on a solution and not have to spend the time, especially given there wasn't a lot of time to understand what the like what you had built there already.
Yeah, thanks.
So that was really nice, very clear.
Good, great.
Well, congratulations to the two winners.
Thank you.
Indeed.
Thank you.
Yes.
Thanks.
Thanks,
All
guys.
right. Have a good one, everyone.
Bye.
Bye.